Hello everyone, welcome back. Today we'll tackle the problem Group Anagrams, Leetcode 49, a great problem to practice and solidify your basics. This problem is part of Blind 75, a curated list of essential coding interview questions. You can find the full list linked in the description below. Be sure to check it out. Now to the problem. In this problem we are given an array of strings and we have to group the anagrams together and return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of another. For example, listen is an anagram of silent, or Nagaram is an anagram of word anagram itself. Then in example 1, the strings eat, tea and ate are anagrams as they can be rearranged to form each other. Similarly, the strings tan and net are also anagram as they can also be rearranged to form each other. But for string bat, there is no other string in the given strings that can be rearranged to form bat. So the final answer will contain 3 lists of grouped anagrams in any order. Now one way to think of anagrams is that they consist of the same characters but arranged differently. For example, in the word eat, if we move the letter T to the start, we will get tea. So to identify anagrams, we can standardize the arrangement of characters in each string. And one simple way to do this is by sorting the characters alphabetically. For example, after sorting the characters in ET and 8, we will get the same string which is AET, showing that these strings are anagrams. Similarly, sorting the characters in 10 and net, we will get ENT, confirming that they are anagrams too. Now, how do we compare these strings? For example, how do we compare this word eat with the rest of the strings in the array? And this is where the sorted string, for example AET, can act as a unique key to group anagrams, where we can use a hash map. Then key will be the sorted string and values will be the list of the original strings that share the same sorted key. For example, the first string we see is eat, which has a sorted form AET, and since the key AET is not present in the map, we insert it into the map with the original string eat in the value list. Next string we see is T with a sorted form AET, and this time the key AET is already present in the map, so we add T to its value list. Next string we see is 10 with the sorted form ENT, and since the key ENT is not present in the map, we insert it into the map with 10 in the value list. Next we process string 8 which has sorted form AET. The key AET is already present in the map, so we add 8 to the value list. Next we encounter net with sorted form ANT, and the key ANT is already present in the map, so we add net to the value list. And finally we see string bat which has sorted form ABT, which is not present in the hash map, so we insert it into the map with bat in the value list. And now we have processed all the strings in the array, and at the end of the process the map contains 3 keys with the grouped anagrams in the map as values, which we will return as the answer. Now the time complexity to sort each string of average length m will be O of m log m, and for each string we check if its sorted version exists in the hash map. If it does, we update its corresponding group of anagrams, otherwise we insert a new key value pair. Both lookup and insertion operations in the hash map takes O of 1 time on average, and we repeat this process for n strings. Hence the overall time complexity will be O of n into m log m, and the space complexity will be O of n into m, because the hash map stores n sorted keys and their corresponding values, where we store n strings with the average length of m, resulting in space complexity of O of n into m. And sorting each string requires temporary space proportional to its length, which will be O of m. Hence the overall space complexity will be O of n into m. Another way to identify anagrams is, instead of focusing on their arrangement, we can rather focus on the character count. If the character counts are the same, the strings are anagram. For example, eat and t both have one occurrence of A, E and T, which confirms they are anagrams. So instead of sorting the strings like we did in the previous approach, we can use a frequency map to group anagrams. For each string in the array, we build a frequency map that counts how many times each character occurs. For example, we can create frequency map for each and t like this. It is essentially a hash map where the keys represent the characters and values are their respective counts. And now we can use this frequency map to group the anagrams in a hash map instead of relying on sorted strings. However, the frequency map that we built here is mutable. Hence, it cannot be used as a key in the hash map. So, how do we convert this frequency map into a reliable and immutable key? And this is where the problem constraint can help us. Since we only need to handle lowercase English letters, we can simplify the frequency map into an array or tuple of 26 integers. Each index corresponds to the count of character from A to Z. For instance, A corresponds to index 0, B corresponds to index 1, C corresponds to index 2, and so on. And finally, Z corresponds to index 25. And now we can set the frequency of the character in the string at the respective indices. For example, each has one occurrence of E, so we set 1 at index 4, one occurrence of A, so we set 1 at index 0, and one occurrence of T, so we set 1 at index of T somewhere here, while all the other indices remain 0. Similarly, we will build the frequency array for each string in the array. And now in Python, we can use this tuple as the key because tuples are immutable in Python. This allows us to reliably group anagrams using these frequency tuple keys. However, Java doesn't have tuples, but here we can use arrays, which themselves cannot be used as hash map keys since they are also mutable. But one cool trick can be that we convert this frequency array into a string representation, which is immutable and can easily be used as a key in the map. One simple way to get the string representation is to join the frequencies using a delimiter such as hash. For example, this frequency array for each can be converted into a string representation like 1 hash coming from index 0 for A, 3 times 0 hash coming from indices 1, 2 and 3, and again 1 hash for index 4 for E, and so on. Alternatively, if you follow constraints, we are told that the maximum length of any string in the array is 100. So instead of using this as an integer array, we can create a char array, because then in the worst case, the maximum frequency a character can have in a string is 100, which is within the range of 0 to 255, which fits within the character range in Java. So now, using this character frequency array, we can easily create a string from it utilizing the string constructor. Now, once we have this frequency mapping as a key, whether as a tuple in Python or a string representation in Java, we can use it to group the anagrams, just like we used the sorted version in the previous approach. For each string, we generate its frequency mapping and check if the mapping key exists in the hash map. If it does, we group the anagrams by appending the original string to its value list. If it doesn't, we add a new key value pair where frequency mapping is the key and the original string is the value. And once all strings are processed, we end up with a mapping like this, where all values represent the grouped anagram, which we can finally return as the answer. Now the time complexity of this approach is O of n into m, because to create a frequency map for each string of average length m takes O of m time, and we are doing it for n strings. Hence the overall time complexity will be O of n into m, and the space complexity will be O of n into m as well, because in the hash map we are creating a tuple or this immutable string of size 26, which takes O of 26, the constant space, and based on this key we are grouping the values, which are list of strings. And since we are storing n strings of average length m as the values in the hash map, the overall space complexity will be O of n into m. Here is a quick code walkthrough of the algorithm we just talked about, with Java code on left and Python on right. First, let's create a hash map in Java or dictionary in Python. This map will store the grouped anagrams, where the key will be a unique representation of the character frequencies of an anagram group, and the value will be the list of strings that belong to the same anagram group. Note that in Python we are using default dict, because it takes a default factory as an argument, such as list in this case. And now, whenever a key doesn't exist in the map, it automatically returns an empty list, eliminating the need to manually check if the key exists in the map. Now we will iterate over each string in the input array and create its frequency mapping, where for each character in the string, we update the frequency at the corresponding index. And once we have built this frequency array, we can create a unique key from it. In Java, we can use a string builder to construct a string key, joining all the frequencies using a delimiter like hash, and then convert this builder to the string object. Alternatively, since the constraints allow it, instead of integer frequency array, we can create a character frequency array and create a string directly from it using the string constructor. Both the approaches work well. Just choose the one that fits best based on the feedback from the interviewer. The string builder based approach is more generic but can be slightly cumbersome. And in Python, we can convert a frequency list into immutable tuple. Now that we have generated the key from the frequency array, we can add the original string to the list associated with that key in the map. In Java, if the key is absent, we can add the key along with an empty list. This ensures a list exists for the key to which we can simply append the original string. In Python, thanks to default dict, an empty list is automatically provided for non-existing keys. This lets us directly append the string to the value list for the key. And after processing all strings, we return the grouped anagrams by converting the values of the map to the list. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.